Hey y'all, Data Guy here. And today I wanted to make a video on just some of my predictions for the future of data science. I know I cover a lot of data engineering topic, cover a lot of data analysis topic, and I made this video on data engineering and people seem to find it helpful. So I wanted to kind of talk about what I'm seeing in my day job and just by being a member of the Dataverse on how I think the field of data science is kind of continue to evolve over the past decade. So going to be looking at things like some headwinds facing data science. What are some things that could really make data science less of a prominent career? Tailwinds, things that could really put a boost into data science careers, and then go into things like emerging areas of interest, new things that data scientists are starting to explore, as well as talking about declining practices. What are some practices that used to be a massive part of the data science world? How are they kind of shifting out of the industry? And then, speaking of shifting, talk about kind of shifting priorities. As data science has kind of matured, it's I guess, in its second, third decade really of formalized existence. How has the priority shifted from kind of what they were at the start of the data science career path, and what do they look like now? So we're going to cover all of that. So tune in and let's get into it. So I want to get the negatives right out of the way and talk about some of the challenges facing data scientists today in the industry. And number one, I would say, is kind of data privacy and regulation. You've kind of seen this, in the news with companies like ChatGPT or OpenAI getting dinged for, processing publicly available data and using it to train their models. But also more, even older kind of data protections such as GDPR and CCPA are challenging the way that data is collected, processed, and stored. And what that means is it's become much more difficult to actually get access to user data than it used to be. Before, a lot of this stuff was publicly available. If you were a company and a user was using your product, you could pretty much do whatever you want with their data. However, that's kind of gone the wayside, thankfully, honestly, for users. But it does make data science harder because you need to find a way to navigate these regulations and get the data you need without compromising the quality of the analytics. So even though it might be harder to actually get access to this data, it doesn't mean that data still isn't relevant and still isn't necessary to actually make informed decisions. A second piece is data quality issues. You'll notice this is the top challenge facing analytics initiatives. And that's because with an explosion of data, as every single piece of technology, every piece of hardware and software is collecting data on your end user, that explosion of data has really brought challenges in data management and quality assurance and making sure that all of that data is stored and checked to actually make sure it is useful. And so ensuring the integrity and usability of large data sets remains a really critical concern in data science initiatives, making sure that you're not spending months and months on developing some massive model only to find out that it doesn't work because your data doesn't fit with that model. And then finally, complexity of models. Complexity of models, the acceleration of AI and ML. As these models become more complex, as you really need the technical floor of being a data scientist continues to raise. It can kind of limit the profession to certain users, and then also as these AI and ML models become even more and more advanced, you're basically just becoming an AI or ML engineer. Because at the end, if all of your data scientists and analysis is routed through ML and AI, you're going to have to know how to manage those systems, and that's going to be the bulk of your work. So if you're not comfortable with those systems, if you are finding difficulty in actually using them, and you might be at a disadvantage in the future of the industry where a lot of that is driven by AI and ML. And if you don't have those skill sets, you might not be able to get a job as a data scientist, because data science is really one of those jobs where maybe not interpreting the data you need a human for, but a lot of the work in processing the data and actually deriving insights from it can be automated and done by these ML and models and artificial intelligence. So something to keep in mind when you're thinking about the industry. These are some of the challenges that you might have to face. So now we've got the negatives out of the way, I want to talk some more about the positives facing the industry. Number one, even though AI, machine learning, it takes a bit to get up to speed on, these innovations in AI and particularly in deep learning are really expanding the capabilities of data science. And growing opening up new avenues for the application of more sophisticated analysis and predictions, and really increasing the data scientist's scope of work away from just kind of traditional dashboards into really more democratized analytics, where every piece of the business is using data to improve and innovate on their processes. Additionally, the increased computational power, the massive growth in computational power, is really set to dramatically increase the processing capabilities available to data scientists. And this is a trend we've seen over the past decade, but I think it's only going to continue to accelerate with things like quantum computing, which is going to really enable the handling of those more complex, larger scale models more efficiently, and also by driving the cost down through cheaper, larger scale compute, opening up the ability to run those more complex, large scale models at smaller enterprises that might not have the budget to stand up all the infrastructure behind it. And then third is wider data accessibility and integration. The trend towards decentralized data ecosystems and really the proliferation of APIs for data sharing are simplifying data access and integration, making data available for many, many more locations. So even though there might be stricter regulations, there's also much more data available as well. And that is really going to have the effect of enhancing the potential for cross-industry data science initiatives by getting data from systems that you might not have been able to previously, and enabling stakeholders who traditionally don't maybe think about data to get involved in this ecosystem. So those are some of the big tailwinds that I see as kind of propelling the data science career path in the coming years. So now I want to talk about some of the emerging areas of interest and kind of trends that we're seeing in the industry, from kind of today, and how I think they're going to evolve over time. And the first is ethical AI and algorithmic fairness. And this is kind of a controversial topic because some people don't think that we should actually develop ethical AI, and they don't think we should have any controls in development because they want to make ethical AI systems that make fair and unbiased decisions, because there's been some evidence that AI has biases towards traditionally, overrepresented groups. And so this focus is likely going to drive research innovation into methods to detect and mitigate bias in AI algorithms. So we'll probably have more kind of automated ways to actually process that data in order to, I guess, alleviate or eliminate kind of the human cognitive bias in your models. Because as we know, humans are writing the machine learning models, and so some of their cognitive bias is likely to bake it into them. Another cool emerging area of interest is kind of the data fabric, data mesh approach, which basically has all these different types of business units, all surfacing data and both consuming data from a kind of centralized analytics clearinghouse, and also, or in another approach, having every team have kind of embedded analytics. And so that opens up a lot of possibilities for data scientists, both to kind of act in a platform role or to be more embedded with a specific vertical if they so choose. And then finally, we have augmented analytics, and kind of shown here is data-centric AI, which is the use of AI to enhance data analytics processes. And this is known as augmented analytics, which is basically taking some of those more manual data analytics processes and using AI to automate them to really just take away kind of more of that boilerplate, non-heavy gray matter load work, and enable more dynamic decision making, because you don't have to spend that time, hey, I want to create a new model, now I got to go spend 80 hours cleaning the data for it. You can have an AI that is able to process and clean the data, and you just have to focus on the more cerebral work of actually defining that model. So those are some of the main kind of business practices and trends I see kind of emerging and continuing to grow over the next few years. So now I want to sum up this video with kind of a comparison and just analysis of like, hey, what are some practices that are really going out of date in the data science and data world, and what are some that are more coming into practice? What are some of the hot new trends right now? And on the declining side, so that's the gray side, manual data automation, really like having things like database administrators, someone that's just a job is just to pull and manage all their data, and just doing kind of all of that manual work. That's really going by the wayside. There's a lot of automated processing now, and with the kind of rise of automated processing, data scientists now have the tools to kind of develop, a framework for, hey, AI can process this data. Now you don't need those kind of administrators or people that are just doing that more clerical work. And kind of with that, breaking out those silos, breaking out of on-premise, really slow and complicated and static data structures into a much more lightweight and modular kind of cloud-native architecture, where you have many different systems that are plugging in and out of each other in almost a network of different systems. And you'll have systems like Airflow even to make those links between all those different data tools within your company's ecosystem. And also, just being much more flexible and agile. Hey, I want to drop my data science, I want to sub in Power BI for Informatica. That's really easy to do now, because you don't have to have that kind of vendor lock-in where you're on a full Oracle stack and you can't interact with anything that's not Oracle. And then also kind of shifting priorities in terms of like type of analytics you're going to be doing from descriptive and diagnosive analytics into predictive and prescriptive analytics. Going away from just saying, hey, what does our data look like? Tell me a story about how customer trends have been over the past year, into more using that data about those past customer trends. How do we expect the future of this year to play out? What can we predict our revenue will be in Q3 of this? And really that's kind of enhance the strategic value of data science, as it's able to not just like analyze what's happened, but really be a driving force in deciding, hey, what is the best path for us to go forward? And so that is all I have for you today. I just want to make this video real quick just to kind of give any data scientists or people that are considering data science an idea of what the future of that career path might look like. And so hopefully you have enjoyed this video and it's helped you to make an informed decision. And I hope you have a great rest of your day. Data Guy out.